computational complexity. So linear SVC in scikit-learn builds on several solvers and is limited to linear decision boundaries, right? So because it does not always apply the kernel trick, its training can grow almost linearly with both the numbers of samples, m, and the numbers of features, n. And convergence is going to be controlled by some tolerance, right? Whatever you're trying to limit your error to. So that's the base of our linear SVC in scikit-learn. And so if we take a look at some of the key characteristics of the three SVC classifiers, we can get a time complexity for linear SVC of OMN. It does not have out-of-core support. It does require scaling, and it doesn't implement the kernel trick, right? So we can also look at SVC. In contrast, the time complexity can be OM to the n squared, which is much more, or OM cubed times n. But it does implement the kernel trick. So as we scale these things higher, or we don't have to scale them as high, we don't have to have as many features, right? So while the time complexity is definitely slower, because we don't have as many features, there is a potential that SVC can allow you to actually save some time. And then you can always, of course, look at stochastic gradient descent classifier for reference. It does have out-of-memory support, so it might allow you to do some larger data sets. It can scale quite well, but it doesn't have the kernel trick, obviously. Not really a relevant comparison, but it's provided there to give you some reference. So just things to think about as you're building large data sets with stochastic gradient descent and what you may want to scale or not scale.